So here we go with this video. We're going to be talking in the topic 2 mechanics. I'm going to be concentrating on the equations of motion. In our data booklet we are actually given these three formulas here, which are equations of motion, but I'd just like to add to them because they are ones that you should know that are not here. So firstly, our acceleration, our average velocity is equal to our distance over time. That's always good to remember. And we have our acceleration is equal to our change in velocity over our change in time. Now, because we have a change in velocity, therefore we have a starting off velocity and an ending off velocity, we actually define this as v minus u over t, where v is your final velocity and u is the initial velocity. So it's this over there gives me a change in velocity, the final minus initial over time. Now if I change that formula around, I've got a is equal to v minus u over t. I can multiply both sides by t, so I can get v is equal to u plus at. I take my u over to the other side, it becomes positive. Now this is actually an important formula to remember. You should always have that one also in your mind. V is equal to u plus at. I actually proved for these to you in class, and if you want me to prove them to you again, I can show you that. But just to explain the rest of the formulas here, this u plus v over 2, that's the initial plus the final divided by 2, that gives you an average velocity. So that's just like when you find the average of anything, take the one, you add it to the other, divided by 2. So that's your average velocity. Your S, let's just make a list here, an important list in the middle. Your S is your displacement. That's what S stands for. The U, as we've said before, is your initial velocity, and your V is your final velocity. Your T, obviously, is your time. That's your time. And your acceleration is given by A. So this is the acceleration, which is important. Okay, so those are your equations of motion. Now, when solving and when using any sort of equation, as we're going to see, we've actually got quite a lot of equations to work with in mechanics. This is important that you do this systematically. And I'm going to go through a few examples now, just to show how you would use these equations in solving problems. But you should always have this in front of you and be ready to use it. Okay, so I've got a few problems over here. And the first one, it says a car is at rest. Now this rest tells us something. It's implied from that something. On a horizontal surface, the accelerator is applied and the car accelerates at 3 meters per second. Now we wouldn't write like that, we would write it like that, 3 meters per second to negative 2. What will be the speed of this car after 6.5 seconds? Now it's important that you bear in mind always your S, your U, your V, your A, and T. We are always dealing in this type of motion in a straight line, and our A is constant. And we are actually told that, aren't we? This is our A here, so identify that that's 3 meters per second to negative 2. We also get told something by this word at rest. A car is at rest, telling us that our initial velocity is 0, so we write that in. And we're also told in the first part that the speed of the car after 6.5 seconds, so we're told 6.5 seconds. Now what we need to do with this is we have to go back to our formulas and decide which formula are we going to use. So perhaps I can just move this over here and we can see both at the same time. But which formula am I going to use? Remember, we've got this V is equal to U plus AT also. Now you look what we've got to find. We have to find our v, our final velocity. The speed and the velocity are the same thing because it's going in a straight line. So we have our initial velocity, we have our acceleration, we have our time. So we're actually going to use this formula over here. So I'm going to get v is equal to u plus at. So we have identified the right formula. This is often the most important part, identifying the right formula. We identify that by knowing what we want to find and knowing what we've got. Unless you've got this, it's very difficult to do. And so we put these values in. So it's at rest, so it's 0 plus a. A is 3 times the t, 6.5 seconds. So that is going to be 19.5 meters per second to the negative 1. Now, as you notice here, I don't put in the units here, but I have to put them in here. Also, looking at the number of significant figures, this worked out fine. It was 3 significant figures, and we see that all our values are given in 3 significant figures. So we wouldn't want to give our answer in more than 3 significant figures. We'd want to make sure that it's not more accurate than our data that we use to solve it. So that's our first question there. The second part over here, B. Got to close that down. B, what will be the average speed of this car during the 6.5 seconds? The average speed, remember, we could write that as v with a little bar. That's u plus v over 2. That would give us our average speed. So that would be 0 plus 19.5 divided by 2. 19.5 is going to be 9.75. Is that correct? 9.75. I'm just doing that in my head. Meters per second to negative 1. And how far will the car move during the 6.5 seconds? So again, I want to pull up my formulas here. Oops, that shouldn't have gone. That's not good. But anyway, I think you saw that. We now want to see how far. So what are we working out? Well, we are working out there the S, aren't we? We're working out what our S value is. We're working out the displacement. So which formula will we use? Well, we could use that formula because we've got all the information for that. We could actually use this formula also because we've got our U, we've got our T, we've got our A, and we've got our T. So we could use that formula. We could even use this formula, but here we'd have to rearrange it. So probably the best one to use would be this one over here. That's pretty straightforward. But I'm going to use this one just to show you how it gets used. S is equal to ut plus a half at squared. U is 0, so that cancels out. It's a half times 3. Now put these in brackets. It's going to be t squared, so it's 6.5 squared. So we calculate that. I'm just going to get my calculator. So we get 6.5 squared times by 3 times by 0.5, and we get 63. Now the whole answer is 375 meters, but I would only write this to 3 significant figures. So I would write this as 63.4 meters, keeping the correct number of significant figures.